Hi there, welcome to the lesson of Introduction to the Logarithm. In this lesson, we're going to understand everything from scratch. Even though no one knows what is the meaning of logarithm, they're going to understand everything by the end of this course. We know this exponentials, right? In mathematics, exponential means, let's say you're going to have a number 2 and you're going to raise a power and you're going to get a solution like something like 8 here. 2 is called like the base, 3 is called the exponent or the power of the base, 8 is the answer we are looking forward to get. If you have this introduction for the exponential, then everything feels easy for you to understand what is logarithm is. Let me get into the video right now. It goes like this. We have exponentials and we have logarithms. Expo and log. Both are the same thing, but it's just the way of expressing. If you're expressing exponents like 2 power 3, you're going to represent the same thing in terms of log that goes this way. Whatever the solution that you have, going to go like here in this place, and the base goes to the base of the log, and whatever the power will be the solution here. And that's it. That's all about the logarithm. Logarithm is just another way of writing the exponential. We must be clear about it. Let me write it down. Log is just another way of writing exponential. I hope you guys understood a little bit about how this logarithm is being created out of the exponentials. So we have three values when it comes to exponents. Let's say you have a b raised to the power a equals to c. This is you call it as exponential. When you rewrite the same thing in terms of logarithm, the base goes to the log base that goes like log with the base of b, and whatever the power will appear as a solution, I mean the answer, and whatever the answer here acts like a question here in this part. I hope this helps. Log is a different way of writing the exponential. That's what we are sticking for right now. In this case, we got the base. For example, let me take a value that goes like mm, 3 power 5, which is equals to 9 times 9 times 3, which is almost equals to 81 times 3. And if you solve for 81 times 3, whatever the answer you're going to get, that's what equals to 3 power 5. Let me quickly do that. 81 times 3 gonna give me 243. If I rewrite the same thing in terms of log, it goes like log with a base of 3 and 243 gonna give me the power of 5. That's it. If you guys can try out these problems, let me say 3 is 4 power 3, which is like 16 times 3, like right, 4 power 2 times 3, 16 times 3, that's equals to 54, and 2 power 4, which is again 16, 5 power 2, which is again 25. If you guys rewrite the same thing in logarithmic form, it goes like log of 54 with the base of 4 equals to, the power is our solution here. And again, log of 16 with a base of 2 gonna give us 4 as a solution. Again, one more time, 25. Log of 25 with base of 5 here gonna give us the value 2 as a solution. So all this thing, all of this question has a different base. Like for different base, we have different answer, and we can able to represent that whatever the base we have in the base of the log. What if you watch out in your calculators, you guys don't see the base value. You guys see something like this. either log or the len. This is the most important thing. It goes something like this. Log means with no base is replaced with the base of 10. Always. A log is called as a common log, which has which always gonna have the base as 10. If any log has a base as 10, you're gonna call it as common log, and that's what we widely use in calculators. Therefore, whatever the log that you see in a calculator has a base of 10. And getting back to the LAN has a base of, let me say, LAN equals to log of natural E, where you call it as natural log. This means simply there will be a constant value for E, something goes like 2.71, etc. And this is a constant that replaces the E. Whenever you see LAN, this will have an automatic base which is equals to the natural E, which is the natural log. You guys must be clear about it. Whenever there is specifically mentioned like log with a base of 2 and 16 here, and that's going to be 4. This represents, I'm only talking about the base 2, which has the power of 4, going to give me 16. In case if I don't have anything like this, but I have something like this, then this literally represents, which is nothing, is replaced by 10. That's going to be equals to 10 raised to the power what? Going to give me 100. Of course, it's 2. Therefore, the answer here is 2. When you use your calculator and you check out what is the value of log of 100, if you type log of 100 equals to what, that's going to give you the value 2, because it is considering the no base as the base of 10. I hope you guys are clear with what is the meaning of a log and the LAN when it comes to the logarithm. So let's rewrite the definition one more time. Whenever you have a logarithm, which is nothing but another way of writing the exponents, it literally says there will be a base, of course, there will be a solution here, and you're gonna find the power here, which is done, which is the alternative way of base rise to the power a equals to c, the exponential form. It literally this particularly says like if you have a base, how much of base must be raised? Let's rewrite this solution. How much or how many times you need to multiply the base to find certain or the given solution or the number. So how many times the basis must be multiplied to get the solution is what the logarithm is. That how many times is what your solution here. Remember, the power being acted in exponential becomes a solution when it comes to logarithm. That's the only difference we have here. So we are clear with what is the definition of logarithm and how this logarithm is built based on the other side of the exponents and how they are related and how we can able to represent any given expression in the form of logarithm, and the major difference between what is log, which is the common log, that means when the base is 10, obviously when the base is e, natural log. Apart from them, if you want to look and work on any logarithm problems, they will definitely gonna mention which base it contains. If they haven't mentioned what base it is, they're gonna just write it line like this: log of 10 raised to the power. I mean, let's say like log of 1000. The answer gonna be 3 because it's pre-understood. It has a base of 10. So lan of 1000 gonna give you something else like I'm not sure what is the lan of 1000 is. This means this is pre-understood. This is including a log with a base of 2.17, etc., which is nothing but log of base e. If you guys are clear with this, Let's move on to the rules when it comes to the logarithm. Just like we have the rules when it comes to the exponentials, like product rule and quotient rule, exactly the same way we have three major rules here. For now, this is enough. We don't need to think and work on all the different ways. Let's understand three major rules. One is the product rule. It says whenever you have a log of A plus log of B, you guys can multiply the values that is written here, which is log of A times B. That's it. And similarly, when you have subtracted, those values can be divided. You guys must be careful about it. Whenever I write something like log of A by B, I meant this. If I'm writing log of A divided by log of B, I didn't mean by this. This is entirely different and this is entirely different. I'm participating the values here, not the entire log. So don't get confused with these two expressions. Let me erase it quickly. So we guys have the quotient rule. Sorry, the first one is the product rule, second one is the quotient rule. And the third one is the power rule. Oh, when it comes to the exponents, powers gets multiplied, but here power do get multiplied but as a constant to the log. What I meant here is let's say you have log of not entire power but for the given value, let's say log of a raised to the power 3 means this can be rewritten as this power multiplies to the log of a. The power is being removed out of it and multiplied with the log and whatever the value you have here. So the general equation goes like log of a power n equals to n log power, sorry, n log a. Always make sure this is not equivalent to log of a whole power n. You guys must be careful about it. So this and this. We got three rules here. We can work on them. Like let's say product rule. If you have something like log of 3 plus log of 5, then you can rewrite them as log of 3 times 5, which is equals to log of 15. You can find the value of log of 15 and you can able to write down whatever the value it is. Suppose if you have something like log of 3 plus again log of x plus 1, which will be equals to 5. At this point, you can rewrite them as log of 3 times x plus 1 equals to 5. And you know one thing, there is no base means the base is nothing but the 10. And we can multiply them. That's possible, totally possible. But according to the definition of a logarithm, this is the base, this is the power, this is the solution when it comes to exponents. So we can rewrite them as 10 raised to the power 5 equals to 3 times x plus 3 times 1, which is 3. Now you can find out the value of x by simplifying it further. And that's how you figure out the value of x, or that's how you solve the given expressions using the product rule. Let's try one more problem. By this time, we're going to make use of the quotient rule. So it's easier when we have a subtraction. Let's say log of 17 divided by 6. At this point, You can able to rewrite the same thing like this: log of 17 minus log of 6. It's the one way of rewriting whatever we have. Suppose if you have an expression that goes like log of 5 minus log of x equals to 2, something like this. In this case, you can able to divide, right? Log of 5 by x equals to 2. And you know this is actually a common log, means a power of 10, sorry, base of 10. That's going to be equals to 5x equals to 5 over x equals to what we got, 10 power 2. To avoid the confusions, this is a guide. Whenever you have exponent base to the power of whatever the power you have and the solution. This solution will be here. The base and the power will be here. Just like we have for logarithm. This can be replaced like log C base B equals to A. That's why I'm going to writing the base, the power together equated to the solution, which is 5 by x. If I solve this thing, I'm going to get something like 5 by 10 equals 100, and multiplying it further with the 10, cross multiplying, I'm going to get, I'm sorry, this is not 10, this is x. I'm going to get 5 equals to 100x, and x equals to 5 divided by 100, that's going to be 1 by 20. That's the value of x. You can able to figure out what is the value of x using the logarithm. That means you're going to solve the expressions and equation with the help of logarithms.